Talking about Johnny, who is a zombie now because if you remember he had cancer, and that was like last year, and he's kicked the bucket by now. But he's back as a reanimated corpse, so hooray for him. And as you know, the primary interest for a reanimated corpse is making sure you've got enough money for the future. So anyway, here's the setup. It starts off fairly normal, and then it starts to depart off. And I might actually grab the question paper off you so that I can give you the right question. So here's how it begins. Johnny's investing $100 at the start of every month. Okay, the interest he's got is 3% per annum, but he's getting paid it monthly, which is kind of normal, right? So 3% per annum, what does that work out to? Well, you divide by 12, so you get 0.25% per month. Okay, so far so good. Now I think one of the earlier parts of the question are, well, let's get an expression for A of n after, where n is, the amount of months you've been going, and what's the amount he's got at the end of the month. Okay, so he's put in his deposit every month, okay, and then he gets the interest at the end, okay. So let's see how familiar you are with this by now. You guys know that what I would ordinarily do is I would build this from scratch. I would say A1 is going to be this, and then A2 will be that plus more and so on, and then I would build it up. I generally feel like doing 3 steps is enough to see the pattern. Okay? After you've got a few steps, you've built it up from scratch, then you generalize. Okay? But let's see if we can generalize off the bat. Okay? So how does this work? What he's going to have is every month $100 is going to go in. Okay? Every month, every month, every month. So I'm going to stick 100 at the front. Because you remember, if every term has 100 on it, then I can take that as a factor out. Okay? Now, then what happens next? Each different amount of $100, right, is going to have a different amount of interest on it, right? Based on how long it's been in. So the first $100 he put in will have the most interest, and then the next one will have one lot less, and then one lot less than that, and so on. Okay? So what kind of series am I going to have in here? Well, the oldest one, the first lot of $100, right, is going to have 1.0025. That's one lot of interest. How many lots is he going to have? Well, after n months, he'll have that to the power of n, right? So just thinking about it, this is the first lot of $100 and how much interest it's got. The next one is going to have one less. So it'll be n minus 1, okay? And so on until the end, okay? Now, the amount of $100, the last one he puts in just before we take the nth amount, okay? How much interest will it have on it? If he puts in money at the start of the month and he gets interest at the end of the month, how many lots of interest will he have? Just the one, right? So I suppose if I put a couple more at the end, I've got 1.0025 squared, and then the very last one will be that. Okay? So what I would say is, this here is the GP, which I want to, it's a geometric progression, so I can take the sum of it, right? I've got my 100 at the front, and then what's the formula for the sum of a GP? Well, A out the front, right? And because your R is greater than 1, so I'm going to put R first. So this is R to the n minus 1 all over R minus 1. So far, so good. So let's have a look. I can think about A from either direction, okay? I can think about this is my A, or this is my A. Conventionally, which would we choose? This one, right? So I'll say 1.0025. There's my A. Going from right to left, what's the common ratio? Well, it's getting bigger by that same amount, right? So 1.0025 power of n minus 1 all over R minus 1. So 0.0025. Okay? Now I think the first part of the question was, show that that's equal to this. I think this is what the numbers come out to if you punch it into your calculator. Okay? Is that alright? So that's the first bit. Then I think they ask you to solve, okay, how many months, as in what will n be to get to a certain amount? I think it's like $3,000 or something like that. So you get a certain amount of months. That's all pretty textbook. I think you guys are okay with that. What I'm interested in with is the next part of the question. Before I get to that and read it to you, I just want to draw your attention to this again. I said we could think of it as a GP from either direction. Okay? So how would it work if I thought of this as the first term? I have my 100 out the front, and then my A would not be 1.0025. What would it be? It would be 1.0025 to the power of n. That would be my first term. Now, that changes a few things in here, doesn't it? Okay? Because my ratio will no longer be 1.0025. What will it be? It'd be that, but I'm dividing. As I go from left to right, I'm dividing by that. So I could say it's 1.0025 to the power of minus 1. Okay? Now since I actually have to raise that to the power of n, that's going to be minus n. Is that okay? Okay. Now, then there's a minus 1. And what happens on the bottom? It's r minus 1. Yes? So 1.0025 to the power of minus 1, minus 1. Okay, now, does this work? Is this true? Is this equivalent to what we worked out before? Does it work out? People aren't sure. How would we verify whether this and this were the same thing or not? Because they look pretty different at the moment. What would you do? You sort of have two alternatives. You could sub some values here. Put in n equals blah for, this one, and see what it's equal to that, and see if you get the same thing out, okay? I think that would work. A better way probably would be to deal with the numbers, okay? How could I simplify this to get closer to something like that? I can do some expansion here, right? Because I've got numbers with the same base, okay? So for instance, on the top here, what would happen? This 1.0025 to the n, and this 1.0025 to the power of minus n, what would they become when I put them together? For instance, okay, let's just take a value of n. If I said 2 cubed times 2 to the minus 3, what would that be equal to? Well, that would be 2 cubed divided by 2 cubed, right? So that part should be 1. Is that okay? What happens to this bit on the end? It's 1.0025 to the end. Okay. Then I have this on the bottom. I'm still not there yet. What must I do? I'm going to have to multiply by something, right? What should I multiply by? Yeah, because I want to get rid of this negative index, right? So if I multiply everything here by 1.0025, and this by 1.0025, see how we go. Okay, so on the top, I've got 1.0025. Okay, so far so good. What happens to the denominator? What happens when I multiply that first term by 1.0025? Becomes 1. And then this one becomes 1.0025. Are we close enough yet? Yes. I think we are, right? Can you see the equivalence between this and this? All I've got is a factor of minus 1 that's the difference. If I multiply by minus 1, this turns around and this turns around and I'm back to where I started. So everything's cool, okay? Now the reason why I point that out is because it looks weird having our A with n's in it. Okay, but you're actually going to need that to solve the next bit. So why don't you jot this down? I'll give you the important details. Okay.